Guys, here we have a Maths Paper 2 exam. If you want to download the paper, check the description below. In the figure, we have point A and point B. Determine the length of AB. So to determine length, we use the length formula. Or you might think of it as a distance formula. Distance and length, same thing. So let's call it the distance. I prefer that. I know most of you do as well. So we're going to go AB is the square root. And then this formula goes, we take the x value of the one point minus the x value of the other point. And then we do the same with y. Okay, so now you just go fill in your formula. Super, super easy. You see how it has brackets? So let's keep the brackets. So it says take the x value of point B. Okay, that's 4. Then it says minus, so we put a minus. And then we must minus this one, so we just put minus 5. Then we're going to take the y value of point B, which is this one. Then it says minus, and then we're going to minus this one. Then you can just go type that in on the calculator exactly as you see it. Please don't change anything. Even when you see 2 negatives here, put the 2 negatives on the calculator. Now, if you do this correctly, we should end up with square root of 97. And if you round that to 2 decimals, it'll be 9.85. And then you could just say units. So 9.85 units. This one says determine the coordinates of the midpoint. Okay, so midpoint, we use a capital M like that, and the formula is, so with this one, you're just going to add the x values together. So it's the x value of point A plus the x value of point B divided by 2, and then it's the y value of point A plus the y value of point B divided by 2. And so now we just go fill in the formula. So it says we take the x value of point A, which is minus 5, then the x value of point B, which is 4. And by the way, don't be so worried about, like, should we put A first? Like, for example, over here, should we put A first or B first? And over here, should we put A first or B first? It doesn't matter. As long as, if over here you chose A, then you must choose A over here. And then if you chose B first over here, then you must choose B first over there. So just make sure that you keep the pattern the same. Where are we? Divide by 2. Okay, now we're going to take the y value of point A plus the y value of point B divided by 2. Okay, so this you can go work out on your calculator. You should eventually end up with negative a half. And then this one you actually just end up with 0. So the coordinates would be negative a half and 0. This next one says determine the gradient. So gradient, we use a small m, and we're going to say the gradient of AB. And now we're going to use the formula y2 minus y1 over x2 minus x1. You know this one, y2. But now because we're using a's and b's, you don't have to do it like this. Sometimes I do it, sometimes I don't. We're just going to rather do that. And you see how I started with b? You don't have to. You could have started with a. It doesn't matter. And so let's go fill that in. So the y value of point B, negative 2. The y value of point A is 2. The x value of point B is 4. And the x value of point A is minus 5. Go ahead, you can just type that in on the calculator. You would get negative 4 over 9. This last one says, point A undergoes a transformation to become the new point A with a little line, such that the gradient of the line, this new A to B, becomes undefined. Describe the transformation. Okay, so let's talk about it. They're telling us that point A is going to move. And wherever it moves to, it's going to become A with a little line, okay? So they said that it's going to move to such a place that the gradient of the point A with a little line, so the new A, B, will become undefined. What is undefined? When a line, okay, so when you have a line that is horizontal, we say that the gradient is 0. But when you have a line that is completely vertical, we call this undefined. Okay? So that means that this A is probably going to move somewhere over here, so maybe there. Or it could even end up moving somewhere down here, so it could be over there. So that when you connect the new A to B, just like they said over here, they said that that gradient will be undefined. So you see how it's a vertical line like that. Now, to try to figure out which one it does, remember they said that it undergoes a certain transformation. So what you need to read there is that it's only going to do one thing. So it's not going to move a little bit down and a little bit to the right, or a little bit up and a little bit to the right. It's only allowed to do one thing. So the only way you could do this is to move it there. So it's going to end up going over there. And then this will be the new A with a line, and then you can see that that line there would be completely vertical, so it would have a gradient that is undefined. So how would you move it from here to here? Well, think about what the x value is over here. Look at this dot. Can you see it has an x value of 4? So because this dot is directly above, it will also have a x value of 4 because it hasn't gone left and it hasn't gone right. So it must have the same x value. And then the y value would have to be exactly the same as this one because it hasn't gone up and it hasn't gone down. It's only gone sideways. So it must share the same y value. So this would be the new coordinates of A. So they said, describe the transformation. Well, what we're going to do is we're going to move it horizontally to the right. Okay, so we're going to move. Now, how many units are we going to move it? Well, notice that this value doesn't change, so we're not going to look at that. But you see how we're going from -5 to +4. How far is that? From -5 all the way to +4. You need to maybe just take some time and think about that, but that is 9 units because you're going all the way from, like on a number line, if you have -5 and then you have 4 and then you have 0 somewhere in between, just going from there to there is already 5, and then going from there to there is already 4, so 5 plus 4 is 9. So we're going to move 9 units horizontally to the right. If A is 78 degrees and B is 34, calculate the following correct to 2 decimal places. Okay, so we're allowed to use a calculator for this. So for this one, you're just going to go say sin of 78 minus the sin of B, which is 34. You can literally just go type that in the calculator. And to 2 decimal places, they said that would be it is 0.41895. But if you round that to 2 decimals, it's going to become 42. Okay, now sec. I don't know about you, but if you look on your calculator, there is no sec. But we know that there's these things that we've learnt about. Sec, it's actually, you only do it in grade 10. It's quite weird. You don't do it in grade 11 again, and you don't do it in grade 12 again. Cot and cosec. What we must remember is that sec is the opposite, or 1 over cos. This one is the 1 over tan, and this one is 1 over sin. So what we could do is we could just replace this as 1 over cos. Okay, and now you can just go type this on your calculator. So to get a 3 outside of a root like this, you say shift. You say shift on your calculator, press the shift button, and then the square root, and then it should open up like that for you. Okay, so you're going to go type 1 over cos A 78. So go ahead, type this all on your calculator, and we should get 1,69 if you round that to 2 decimals. In the diagram below, point P lies in the 3rd quadrant. They tell us that the length of OP is R, and that's all that's really important. Now it says using the sketch and without using a calculator, what is the length of OP? So what is the length of this over here? So what you need to understand is that point P has these coordinates, okay? So even if I take away all of these lines, if you just ignore all of that, let me actually try to erase it. Okay, so even if you had to take all of this away, okay, and even this box we can take away. Now if you had to look at this coordinate and this coordinate, it means the x is -2, so it means it's 2 to the left, so that length there is 2, and then it's 1 place down because the y value is 1 down, so I'm just going to say 1 down over here, so 1, that length is 1. Now if I had to bring the triangle back, then we can say that this length over here is 2, and this length over here is 1, you might want to put a minus because we know that the coordinates are negative, and that's negative over there. And now we've got the lengths of the triangle. So you see how coordinates help you to find the lengths of a triangle? So how would you find this length? Well, that's easy. You just use Pythagoras. And so you don't even have to put the negatives on the calculator. You can just say that OP squared is going to be equal to 2 squared plus 1 squared, because we're just looking at the length. So the negative doesn't come in when you're just looking at the length. And so that's going to end up giving you 4 plus 1, which is 5. And then you take the square root, and that's just going to give you square root 5. Leave it as square root 5 like that. Don't go and change it to decimals and all of that with these kind of questions. Okay, this one says, without a calculator, calculate the value of that. Okay, so it looks intimidating, right? But it's going to, trust me, it's going to be something quite nice. So let's go have a look. They said square root 5 cos theta. So cos theta. So we're going to go to this triangle and we're going to go find cos. Now remember, we can use SOHCAHTOA, but you might use something different. You might use X, Y, R. There's many different ways that teachers teach. It's all correct. But we're going to look at cos, and I like the sin, cos, tan, or the SOHCAHTOA method. So cos theta is going to be equal to A, which is the adjacent. So if I look at this angle here, remember, when they say cos theta, I know theta is this thing on the outside here, but you're just going to pretend that we're over here. Now, what is the adjacent? Well, this would be your adjacent, this would be your opposite, and this would be your hypotenuse. So cos would be adjacent, which is minus 2, over your hypotenuse, which is square root 5. Okay, then the question says plus 4. Now there's a cosec squared. Don't worry about that. Don't worry, it's not that difficult. It looks a bit weird. But what we must remember is that we've got these 3 things that we learn about in grade 10. Sec, cot, and cosec. Okay? All you must remember is that sec is the same or the opposite of, so it's 1 over cos. Cot is 1 over tan. And cosec is 1 over sin. So the cosec that we're looking at is 1 over sin. So it's the opposite of sin. So if I look over here, I know that sin is opposite over hypotenuse. So what is the opposite of that? Well, the opposite of that would be hypotenuse over opposite. So then I can open up this bracket, and the square, that literally just goes over there. So what is hypotenuse over the opposite? Well, the hypotenuse is this one, which is square root 5, and that's always a positive. And then the opposite is minus 1. There we go. Now, they still said don't use a calculator, so if you had to just go type this all in on the calculator, the teachers would figure that out. So all you must realize is that this and this would cancel because the 1 is at the top and the 1 is at the bottom. And so you end up with minus 2. And then this part over here, or this part here, you're going to square both. So you're going to square this, and then you're going to square that. You can type those parts in your calculator. So you could type that on your calculator, square root 5 to the power of 2. It's just going to give you 5. And then you could type that to the power of 2. But make sure you do it in brackets. It'll just give you a 1. And so suddenly we have minus 2 plus 4 times 5. Now 4 times 5 is 20. Minus 2 plus 20 is 18. Evaluate without a calculator. So you look at this crazy thing and you think to yourself, how did you end up in this position where you are now being asked to calculate this without a calculator? Well, remember, when you see the common angles 45, 30, and 60, we have special triangles. So let's go draw those out. We've got one that has a 45 and a 45. So because those two angles are the same, remember that these two lengths are the same. And then if you had to use Pythagoras, you would actually realize that this is just square root 2. So that's our first triangle. The next one is the 30, 60, 90 triangle. Now, it doesn't matter if you put 30 there or 30 there, but what I like to do, wherever I put the 30, I know that the 1 must be on the opposite of that. Okay? Then I know that the other one is a square root 3 and the hypotenuse is a 2. If you don't know this, it'll literally take you like 5 minutes to memorize. And so now we can use these triangles. So the first question says sin 45. Now sin or SOHCAHTOA tells us that sin is the opposite over the hypotenuse. So sin is opposite, and it's the sin of 45. So you could use this one or this one. It doesn't matter. So I'm going to use this one. So that's the opposite, and that's the hypotenuse. So it's going to be 1 over square root 2. Okay, then I'm not going to do anything with that. Now, don't ever let these squares make you nervous. I've got grade 12s who still get nervous about that. Just put it in a bracket and square whatever tan 30 is. So tan 30, so we're going to come down here now. Tan is opposite and adjacent. So tan opposite and then adjacent, square root 3. So you just put it like that. Okay, now, they say without a calculator, guys, but you can use a calculator in certain parts. I'll show you how to do it. You just got to do little pieces at a time. So don't put all of that on the calculator, but what you can do is put that on the calculator. And if you do that, you're going to end up with 1 over 3. Okay? Now, in the next step, put that on the calculator. So that'll give you square root 2 over 6. Now what we do, you see how we have a fraction on top of a fraction. So I wouldn't type that all in on the calculator. Teachers might suspect that you just used it. So remember, when you have a fraction divided by a fraction, you keep the first fraction as it is, you then change it to a multiply, and then you flip this one upside down, so it becomes like that. Now this you can type on the calculator, and it's going to give you a final answer of 3. Sketch below shows the graph of f of x, which is, okay, let's do this quickly. Let's say f of x is that equation there, and they've told us that it's this one, so there. And g of x, which is then this one over here. First, and then it says for the interval 0 to 360, so we can see it goes from 0 up to 360. Now, this first question says, write down the period of g. Now, period is for a sin and cos graph in grade 10 is always just going to be 360 degrees. In grade 11 and 12, that can begin to change, but for grade 10, 360 degrees. So the answer, when they say what is the period, we're just going to say 360. Okay, for which values of x will the graph of f, so the yellow one, be bigger than 0, bigger than or equal to 0? Now what this means is above the x-axis. So where's the x-axis? Well, the x-axis is this one. So this question over here is actually just saying, where is that yellow graph above the x-axis? So we can see it's above the x-axis over there, as well as over there. So when we give our answer, and I'll show you how to do it with interval notation, and I'll also show you how to do it with, if you prefer to use these symbols over here. So for interval notation, you will just say that x is an element going from, now for this one over here, we can see the x value goes from 0 up to 90. We will include the 90 because they are also including over here. And then you could say or, and then you would have to go give this one over here, which is now going to be from 270 up to 360. Okay, if you prefer to use the set builder, you could just say x is bigger than or equal to 0, smaller than equal to 90, or, and then you could just say 270 up to 360. Please remember that this sign over here has nothing to do with these directions over here, okay? You got to understand carefully what this means. It means x is bigger than 0, but smaller than 90. So x is somewhere in between 0 and 90. That's what we're saying over there. And then for this one, whoops, don't know what happened there. We're saying that x is bigger than 270, but smaller than 360. So it's somewhere from 270 up to 360. This one over here says, determine the range, remember that's the y values, of m if m is equal to that. Okay, so immediately I realized that they have the graph f. So I'm going to ignore this for now, and I'm just going to go look at the graph f, and I'm going to go look at its range. Okay, so the range is the y value. So what is the smallest y value you can see? Well, I can see it all the way over there at -1. Okay, so I'm going to say from -1. And then what is the highest y value you can see? Well, it's this dot or this dot. And I can see that that has a value of 1. Oh, I keep doing that. And so that is the range of f of x. So now they said, what is the range of m if m is multiply f of x by -4? So I'm going to multiply all of this by -4. So that would become +4, -4. But I know that range must always be switched around, so I'm just going to write it like this. Okay. And then they want us to add 1, so we're going to move the graph up by 1. So where would -4 go? It would be over here. And if you move it up by 1, it would go to -3. So I'm going to put it at -3. And then where would 4 go? Let's say 4 was over here. If you move it up by 1, it's going to go to 5. And so that would be the answer for the range of m. This is the kind of question to give you an absolute heart attack, right? But let me quickly show you. It's really not that difficult. I'm going to show you how to work through it nice and slowly, and eventually we'll get it. So it's a 4-mark question. They tell us that angle A is theta. We've got that. They tell us that this is 90. We've got that. They tell us that this is x. Got that. That is equal to that. And we've got everything. Okay. Now look at this, guys. They want you to eventually find AB. So this is the unknown over here. So what happens is that for 4 marks, you definitely won't be able to start in this triangle. There is not enough information. So what we do is we're going to start in this triangle. Now, you tell me. Well, you can't really tell me because this is a video. But I want you to think about this very carefully. We're going to work in that triangle first that I've highlighted in red. What do you think is the side? Which side do you think we should try find so that it will allow us to work in this triangle next? Should we try find this side over here? Should we try find this side over here? This one here. Well done if you said we should try find this one, because that one is then going to allow us to work in this triangle in the next step. So all that you now have to do is don't even worry about this. All I want you to now go and do is find this side over here. Okay, this one. Go find that. So how do we do that? Kevin, there's no numbers. Don't worry, you just got to get comfortable working with letters. So, not lettuce, the stuff that you eat. Letters. Okay, that was lame. Sorry. Here is an angle. So we've got this angle. Okay, even though it's just a weird letter, pretend that we have it. And we also have this over here. So in that red triangle, what is this called? Is this the adjacent, the hypotenuse, or the opposite? So because it is the one that is opposite the 90, we call it the hypotenuse. Okay? From this angle over here, the one next to it is called the adjacent. And the one opposite that angle is called the opposite. Now we need to think about sin, cos, and tan. So SOHCAHTOA is the one I like to use. Okay, so the thing we're looking for, we said we're going to try find this length over here. So we're looking for the opposite. And what do we already have? We already have the hypotenuse. They've already given that to us. So we're going to use the one that has opposite and hypotenuse. That is sin. So we're going to say sin of the angle. Sin of the angle. What is the angle? Beta. Now equals to opposite, which is the length BD, right? That is the opposite, BD, over the hypotenuse, which is X. All I'm going to do now is I'm going to get this by itself. How do I get that by itself? Well, I need to get rid of this X. So what I'm going to do is I'm going to multiply this side by X, because and then what I do to the one side, I have to do to the other side. The reason I've done that is so that these two can now cancel each other out. And now I'm left with BD is equal to X sin beta. So look at that. We have found BD. So now I can fill BD in as X sin beta. Okay? Now I can get rid of all of this stuff. I don't need this triangle anymore. Thanks, triangle. I don't need you at all. You can get out of here. So now what I can do is I can work in this triangle. And I've got an angle. Here it is over here. Okay, so from that angle, Or let's first go label. So we know that the one that's opposite the 90 is always called the hypotenuse. So this is the hypotenuse of this triangle. The one that is next to the angle, so that would be this one, that is the adjacent. And then the one that is opposite is obviously called the opposite. Okay, so I want the adjacent, and I already have the opposite. So that means I would use tan, because tan uses opposite and adjacent. So then I'll say tan of the angle equals to the opposite, which is this. But I'm not going to write that because that looks ugly. I'm rather going to call it BD for now. For now, I'll call it BD. And then the adjacent, I'll call that AB. Okay, now here's where things get a little bit tricky. We have to try get AB. That is what we're looking for, right? We are looking for this side AB. That's what they've asked us to do. So you need to somehow try and get this by itself. So all you're going to do is the following. Let me just write this a little bit better over here. You need to somehow take this to that side. So all you do, check here. You're going to multiply this side by AB, and what you do to the one side, you have to do to the other side. Because look here, these two can now cancel each other out. And so now we are left with BD equals to AB tan theta. Okay, now we can divide this side by tan theta, and what you do to the one side, you do to the other side. Why did I do that? Because now these can cancel, and so all that we have left is on the left is AB. And on the right we have that. Now we know what BD is. We know that BD is that. So now I can go fill it in. See, I only fill it in at the end. I don't want to write x and beta the whole time. And that's exactly what they wanted us to find. So you see how I kept writing it as BD, 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 BD. Only at the end, when I was ready, did I change it to that. Otherwise, you would have had to say x and beta, x and beta, x and beta, x and beta. It just gets long having to write that the whole time. This one says, hence or otherwise calculate the length of AB. Okay, so they want us to calculate AB now. If theta is 52, okay, so we have theta is 52, beta is 40, and x is 12. Oh, easy. We're just going to go fill it in, bro. So x is 12, beta is 40, and theta is 52. So we're just going to literally go type that all in. And the answer is 6.026. But if you look here, they said write your answer to the nearest whole number. The nearest whole number would be 6. So we can say 6 meters because they've used meters over there. Complete the theorem. The line segment joining the midpoints of two triangles. Okay, so let's draw a triangle. And then they said the line segment that joins the midpoints of the two sides. Okay, so if this is the first side over here, let's put the midpoint over there. And then if this is the next side, let's put midpoint like that. And let's put this one's midpoint over there. So when these are midpoints, it means that this length is the same as this length. And then this length is the same as this length. Now they said the line segment that joins those two. Okay, there. They say, okay, now you need to know from grade 10, this is grade 10, midpoint theorem. The midpoint theorem tells us that if you have a triangle, and if you take the midpoint and the midpoint of the other side, and if you connect them, then automatically this line becomes automatically parallel to this one. It just happens. You can try to draw this out 100 times on your page. It just happens. It's amazing. And another thing is that this length will be exactly half the length of that one. How awesome is that? So it says the line segment joining the midpoints of two triangles of a triangle is, now we're just going to say parallel, or let's rather say, we can say parallel to the third side. This is the third side, and it is half the length of the third side. Okay, perfect. So that's the midpoint theorem. This question over here says ABCD is a rhombus with diagonal AC has a length of 16. Okay, so this length over here is 16. And DB, the other diagonal, is 30. Okay, now first question says, calculate the length of BC. Calculate the length of BC. Okay, so BC is over here. Right, let's go talk about a rhombus quickly, just so we can refresh our memory. So a rhombus has all four sides the same length. Whoa. All four sides are the same length. So that is the same as that, that is the same as that. So they all four have the same length, okay, if you didn't hear me the first time. Now, they've obviously got diagonals. The diagonals are not the same length. I mean, look how long that one is, and then look how short that one is. They're not the same. Another thing, the diagonals bisect each other at 90 degrees. Okay, so bisect means that it cuts each other in half. So this length and this length is the same, and then these two are also the same as each other. Okay, those are the main properties of a rhombus. Okay, so check this out. If they want the length of BC, okay, they want this length over here. We know that these are all 90, 90, 90, 90. Then what it means is that I could make a triangle just over here. I could make a triangle. And it's a 90-degree triangle, because we know that for a rhombus that's 90 degrees, right? That's just one of the properties. I'll show you how to get 4 marks now. Now I'm just quickly explaining. Now, we also know that this entire length is 30, but that then means that this part's 15 and this part's 15, because we said here that the diagonals cut each other in half. And if this whole part is 16, then it means that half of that is 8 and half of that is 8. So in this triangle, I can now use Pythagoras, because I have this and I have this, and it's a right angled triangle, so I could find that. That's the idea, but now we've got to go write it down properly for 4 marks. Okay, so what did we say? Well, the first thing we said was that this was 90 degrees, so we can't just call that O, because O could be this one, this one, this one, or this one. So what we instead do is we say BOC, BOC, or COB, whatever you want to do. See, BOC. So now it's that angle over there. So we'll say angle BOC is 90 degrees. And that is just because of a property of a rhombus, because of the diagonals. So you can just say diags of rhombus. Okay? The next thing, what did we say? Oh yes, we said that this length is the same as this length. So we said that BO is equal to OD, and that is also just diags of rhombus. And so therefore BO is 15. The next thing we said was that AO is equal to OC, and that's also because of diags of rhombus. And so therefore we said that OC is 8. And so now it's just a matter of doing Pythagoras. So we could then say that BC squared is going to be equal to OC squared plus OB squared, and that's just because of Pythagoras. And so BC squared is going to be equal to 8 squared plus 15 squared, and so BC squared would be 289, and then of course we square root, we square root that, and that'll be 17. So the length of BC is 17 centimeters. This one says, calculate OF, the length of OF. If OF, okay, is parallel to DC with F on BC. Okay, so they want this length over here if these are parallel. Okay. Okay, so they're sort of getting at the midpoint theorem, and that's probably why they made us do this one over here, because check this out now. If we just look at that triangle, I'll show you now. If we just look at this triangle here, we can see that this is already 15 and this is already 15. So this is the midpoint, okay? And we know that these two lines are parallel. So you know earlier up here I said the following. I said that if we have a triangle where we have the midpoint, so the midpoint there and the midpoint there, then we said these lines are parallel. However, it works the other way as well. If we have one of the midpoints, only one of the midpoints like we do over here. But if they tell us that these lines are automatically parallel, then we can say, therefore, these two must be the same. Okay? And we don't even have to say that those two are the same. All we know is that as long as we have two of the properties, so as long as we have that, because you see up here we had how many properties? We had midpoint plus midpoint, and from that we could say everything else. Here we've got midpoint plus parallel, so now we could say everything else. So one of the things we could say is that this length is half this length. So that means this length is going to be half of this length. But we know this length. Why? Because we've just calculated this one as 17, but we know that the properties of a rhombus tell us that all lengths are the same. So now we have this length, so we can easily get that length as half. But obviously for 3 marks, we need to go and say it in the correct way. So the first thing I would say is, let's go say that CD is 17, or CD is going to be the same as BC. And that's just because of the sides of rhombus. Okay, so therefore CD is also going to be 17 centimeters. Now we can say that OF is going to be half of CD. And that's just midpoint theorem. Midpoint theorem. Okay, now we can literally go and say, therefore, OF would be half of 17, which is 8.5 centimeters. And so we've got that. So just coming back to this midpoint theorem, as long as you have two things, so if you have the midpoints, then you can automatically say these are parallel and this length is half of that. But maybe they give you another scenario where they only give you one of the midpoints, but then they tell you these are parallel. Then from that, you could say these two must be the same. So they can give it to you in different ways, and as long as they give you two properties, you can fill in all the other properties. If your teacher over here uses the reasoning converse, some schools leave that out in grade 10, but then you can also use the word converse if your teacher does that, okay? This question over here says, determine the size of OBF, so angle OBF. So O, then go to B, and then go to F. OBF. Okay, so it's this angle over here. They want to know what that angle is. And they're saying OFC is 64. So OFC is 64. Okay. Now, to be honest, I'm not even going to use the 64. I'm just going to look at this triangle over here once again. We have, if I just draw that triangle out, we've got a 90-degree triangle. We've got the lengths of all three sides, and we're just looking for this angle over here. So we can just use trigonometry. And you could, because we have all three sides, you could literally choose whatever you want. You could choose sin, you could choose cos, or you could choose tan, and you'd get the same answer for every single one of them. So this is B1. So, because opposite of that angle is this one, so this is the opposite. The longest one is the hypotenuse, and the other one would be the adjacent. So you can choose whatever you want. I'm going to go with sin. And so sin of the angle we are looking for, which is angle B1, is equal to the opposite, which is going to be 8, over the hypotenuse, which is going to be 17. And then to get the angle, I'm going to say shift on my calculator. So say shift. So just say shift on your calculator. And then sin, and then 8 over 17. And if you do that correctly, it should give you 28.07 degrees. If you did use the 64 and you used some parallel line kind of method, you would have gotten an answer for B1 as 32. Okay? Slightly different answers. They haven't set the question up correctly. This probably isn't actually 64. They've set it up in a weird way. So yeah, if you use the sin or trigonometry method, you get that. But if you use the parallel method, you get 32. So yeah, I'll quickly show you this parallel method. We know that these lines are parallel, this one and this one, okay? And also this one. They're all parallel. So what that then means is that, can you see there is, let me use a highlighter. Can you see there's an F over here, right? And so it means that from the F, this angle must be the same as this angle over here. So B1 and 2 together is 64 degrees. But another property of the rhombuses that we haven't spoken about when I was showing you the properties is that the diagonals cut the angles in half. So this angle is always the same as this angle. This angle is always going to be the same as this angle. So if these two together must add up to 64, but these two angles are exactly the same, then that means they would actually just both be 32 and 32. Okay, so that's the other answer if you did it that way. Okay, last one. Determine the area of the rhombus. So to determine the area of this rhombus, it's actually going to be quite simple. All you must realize is that we have 4 triangles. Can you see? And all 4 triangles are going to be exactly the same. They're all going to have an 8 and a 15 and a 17, 8, 15, 17, 8, 15, 17, 8, 15, 17. So we're just going to go find one of the areas of the triangle and then just multiply that answer by 4. So if, for example, we look at this triangle here, we know that the area of a triangle, so the area of triangle BOC, is just going to be half base times height. So the base and the height must always be the ones next to the 90 degree. Okay, don't use the 17. So we're just going to say half 8 times 15, and that's going to end up giving us 60 centimeters squared, and then we're just going to times that by 4 because there's 4 of those triangles. So 4 times 60 will just be 240 centimeters squared.